Okay, so yesterday we focused mainly on just a regular square root. We're going to now talk a little bit about what happens if they start changing that index in the square root sign. So instead of a 2, which we talked yesterday, they normally don't write the 2, but instead of that emptiness, I guess, where a 2 would go, they're going to start putting other numbers like 3s, 4s, and then we'll even get into if we have fractions. What do we do? So just like we had perfect squares, we do have perfect cube numbers. And I'm going to write down the first couple. So again, these would be good to write in your notes just so you can refer back to them. But this would be any number raised to the third power. So yesterday we wrote out our perfect squares list, like our 1, 4, 9, 16, 25, 36, all of those numbers. We can do the same thing with numbers to the third power. Now these are going to start to get pretty big pretty fast because you're taking it times itself 3 times. So 1 to the third is still just 1. 2 to the third power would be 8. 3 to the third would be 27. 4 to the third is 64. So you can kind of see how these are already starting to get pretty big. The next one, 5 to the third would be 125. And 4 to the third is up at 216. Now I'm just going to kind of stop there because again, like yesterday, I said chances are not likely you're going to be working with really gigantic cubes. You're going to probably be working with the smaller ones, but just know that there are more. But you can kind of see how quickly those start to go up. For me. Okay. Now let's talk about how to evaluate and perform these operations like we were doing yesterday, but instead of having just a square root, we're looking for the perfect cubes to go inside. So for 40 is not in my list up here. It's underneath the cube root sign. I want to be able to break that 40 down, just like we did yesterday. Are there any numbers from that list I even wrote up there that could go into 40? 8. So just like yesterday, I'm going to rewrite this as the cube root of 8. And then 8 times what is 40? 5. Good, 5. So then it's going to be the cube root of 5. Now, the cube root of 8 is 2. So this just becomes a 2. And then I can't do anything with the 5. So that's going to just stay. And then that little 3 should be up there in the corner. Don't forget that little 3. If you forget the 3 there, then you're saying it's 2 square root of 5, and that's totally different than the cube root of 5. So you want to make sure you're keeping track of what kind of root am I working with here. But you can see how that works very similar to what we did yesterday. It's just now we're talking about larger roots. We're not just talking about a square root here. Okay, now just like yesterday, those properties where we said you can like combine things if they're not underneath the same root sign, you can combine them or you can separate them. You can kind of do them both ways, just kind of depending on what works best for you. So I'm going to take care of that with this one. I'm going to split them. So I'm going to do the cube root of negative 125 and the cube root of 27. Okay, now yesterday we talked about like we won't see negatives underneath the square roots because we're not dealing with imaginary numbers, but you might see negatives that show up underneath something like this with the cube root. Because if you take a power times itself an odd number of times, then you are going to get negative numbers. And that's okay, because I could think about what number times itself 3 times would get me a negative 125. Well, the regular cube root of 125 is just 5, but if I had a negative 5 times negative 5 is 25. But then if I times another negative 5, it switches back to negative, and I'm up at that 125. So it's okay to have negatives when it's underneath an odd root like this, because you're not going to run into any of those weird cases of imaginary numbers. What's the cube root of 27? 3. So this would be my answer. Negative 5 thirds. All right, if you guys flip over to the next page here, we're going to talk about rational exponents to kind of finish us off, which is when you have an exponent that's written as a fraction. Technically, all square root functions are technically items raised to something with a fraction exponent. Okay, here's what I mean. If I had something like the square root of x, okay, that's pretty plain. That's normal, what we saw a lot yesterday. What this really means happened is I took x raised to the 1/2 power. Okay, where do those numbers go when I write it in that square root form? Well, the top number, that goes with the term underneath the square root sign. So it's x to the 1st power. And the 2, that's the number that goes in the index of your square root sign. So remember how I said all regular square root signs technically have a 2? That's where that 2 is at. It's hiding in there. It's just most of the time we don't write it. Because if we did that, just like if we wrote all the ones that stood in front of letters or all the ones that are those exponents, it just kind of clutters up our math problems. So in some of those that are really common, we kind of start to get rid of them. But imagine if I had like the cube root of x, then this would be written as x to the 1/3 power. Because again, x is still raised to the 1st power underneath that square root sign, but now it has a 3. So if I wrote something like this, the 5th root of x squared, how would we rewrite that? X to the, 2/5, the 2/5 power. So you can kind of go back and forth. You can write it as a square root function, or you could switch it so that it has a rational exponent. The other thing I just want to say too is a lot of times they might switch a little bit of the order of how they put the numbers. So another way that we could maybe think about that x to the 2/5 power, instead of me writing it out with the 5th power on the index and then that squared is on the inside with the letter, that squared can kind of move. So it could also say this. So it can kind of switch where they place that 2. So I would just be aware of that because they will sometimes just switch up the notation because they feel like it. They're trying to keep you on your toes a little bit. But they all mean, like all 3 of these here mean the same thing. It's just 3 different ways to write that. Okay, we still have to think though about negative exponents here because sometimes when you're dealing with roots, especially if it's an odd square root, you might have negative numbers. When you translate that though with the exponents, you still can't have negative exponents. So if we have issues with that, we will have to resolve that before we can finish our problem. And that's kind of what that last little piece here says. All right, so what I want to do to finish this off is I've got a couple examples with rational exponents. I want to rewrite them in square root form, and I want to simplify as much as I can. So this first one, I've got 27 raised to the 4/3 power. First thing I would do is let's rewrite this as something with the square root sign. Okay, I know 27 is going to go underneath it, but where does the 4 and where does the 3 go?
The 4 goes with the 27, and then the 3 goes like outside of it.
Good. So you could write it like this, or guys, you could write it like this. Either way works. And then if you write it the first way versus the second way, it might change a little bit of how you approach the problem. So like on the first one, some of you might say, okay, well, I'm going to take 27 to the 4th power, and then I'm going to try to cube root it. Okay. Or some of you might be thinking, we talked about 27 in my list of perfect cubes earlier, right? What is the cubed root of 27? 3. So that kind of breaks that number down to something smaller. Like this becomes a 3. And then I still have that 4. So it's 3 to the 4th power now. Do we know what 3 times 3 times 3 times 3 is? 81. You can handle that either way. Like if you do it the other way, 27 to the 4th power is going to be huge. Okay, but then you would cube root that really large number. You should still get 81. So it doesn't really matter how you approach it. It just maybe how you want to work with numbers. You know, if you don't like to work with really big numbers, then I would go with that route there on the right side. Okay, now if you look at the next one, we're multiplying these terms. But remember when we talked about multiplying things with like bases, we add their exponents together. We're going to do that here. So I'm going to multiply the 2 and the 5 like normal. What's 2 times 5? 10. Now for my x, I have to add 4/3 plus 1/2. Okay, if you want to go about this the long way and find common denominators and add them, you can. Also, though, you have a calculator that you can use to quickly add fractions together. It might make that process a little bit faster for you. What is 4/3 plus a half?
11/6.
Yep, 11/6. Okay, now let's think about how we could rewrite this so that it's in square root form. I can't really do anything with that 10. The 11/6 does not apply to the 10. Okay, so the 10 is just honestly going to kind of tag along with the rest of this problem here. But let's talk about the 6 now. It'd be x to what power? The 11th. And then that 6 comes out here. Think about when we worked with letters yesterday. If we had like x squared underneath the square root sign, they would cancel off. Now, I'm not dealing with squares right now. We're working with a little bit more complicated of a root here. But is there a way for me to maybe split that x to the 11th so that I get a 6th power? So I could maybe take an x out? If you take 11 and you like split it and you have one of them with 6, how much would the other one have to have? 5. So I'm going to rewrite just this piece here. Again, like I said, 10's just kind of tagging along. We're going to do underneath here x to the 6th power and then x to the 5th power. I'm doing that because I can now simplify that x to the 6th power since it's underneath the 6th root. Again, if you really wanted to, you could split these into 2 separate roots, if that maybe makes a little bit more sense. So you can really see, okay, this one's going to simplify, this one's not. What's my answer going to say at the very end here? 10x. Good. Yep, 6th root of x to the 5th power. It's kind of a mouthful when you have to say it all. But yeah, the 10 comes down. This just becomes an x. This has to stay because there's nothing else we can do to reduce that. So this is your answer. Any questions about that?
Yeah. Why isn't the 10 going down?
Underneath the radical sign. Back over here, when the 2 and the 5 started, they were outside of the x. Like, do you see how they weren't raised to anything like that?
Yeah.
Only the x's are. So the numbers just act as normal, and that's why they stay out front. Now, if the 2 was raised to a fraction, like a half, and the 5 was 2, then it would be underneath the square root sign. But right now, these are both just raised to the 1st power, which means they're just plain Jane numbers, and you don't have to do anything special with them. Does that help?
Yeah.
Any other questions? All right.